In this video, we're going to look at for loops. For loops are the best loop to use when you know or when you can calculate how many times the loop needs to run. So in our previous examples on while loops and do while loops, we used it for input validation. We don't know how many times it's going to take for that user to type the correct value, so we used a do while loop, and eventually it'll test true or false. And that loop can run as many times as it needs to. But a for loop is what we want to use when we know how many times something needs to run. So let's take a look at the general form for a for loop. And I want to compare it to a while loop and see that they're not a whole lot different. But one is easier and more concise to read when you know how many times the loop has to run. So let's take a look at a for loop general form. For loop, and we have inside here we have several conditions actually. We have a condition, but we also have an initialization and an increment operator, increment or decrement operator. It could be a lot of different things there. So inside the parentheses on a for loop, we don't just have a condition. We have this initialization of some kind of counter. Remember I said a for loop is when we know how many times we want the loop to run. So that means we're going to have something that counts those loops, and we can initialize it right inside the loop. Okay. Then we have the condition we're going to test to see if the loop should keep executing. And then we have the increment expression. And this is the thing that will change the counter so that eventually the condition will test false and the loop will end. Okay. So we put all three of these inside the parentheses. And then we have a block of statements inside our curly braces. And those statements will repeat until this condition tests false. And the condition usually involves the counter and the increment expression. Okay. So let's look at an example. This is the same example we saw in a while loop a little bit ago, and I'm going to go back to that loop and show you that all the things from the while loop that we did are here in this for loop. It's just a much easier form to read, much easier way to code it. So we start out with that accumulator variable for the sum. Remember I talked about that, but we didn't ever set a value for I before our loop started. So here's our for loop. And here are the three parts that go inside the parentheses on our for loop. The first thing is initializing the counter. Let I equal 1. So our counter is going to start off, our counter is going to be I, and it's going to start off with the value 1. And we declared it and initialized it right inside the for loop. And here's the condition we're going to check each time. We're going to check to see if I is less than or equal to 5. And then right here we're going to increment I by 1 each time our loop executes. So each time our loop executes, the value will be 1. We'll add 1 onto the sum. Next time around, the value will be 2. We'll add 2 onto the sum. And that will repeat until finally I gets up to 6, and this fails, and it'll alert the sum. That's the exact same thing that happened with the while loop. So initialization, condition, and the increment. Let's go back and look at that while loop that we did. We had initialization of a counter variable outside of the loop. We had a condition that we tested. And then we had something that changed the value of the counter variable so that eventually the condition would become false. So all three of those parts were here in the while loop. Okay, in this particular while loop. So this is one of those ones, we wrote it as a while loop, but it's much more efficiently to write. It's much more efficient to write it as a for loop. So when you know where you're starting, where you're ending, or if you can calculate them somehow, for loop is the better way to do it. It's more concise and easier to read. And then the only thing that goes inside the loop is the logic. We don't have to worry about changing the conditions. The condition automatically gets changed as part of the loop. So let's look at some examples. So here's a loop that calculates the value of an investment. So this is an investment of $10,000. stored in this constant called investment, an annual rate of 7. And then we have a number of years that we're going to do the investment. We're going to let the future value equal the investment. So it's going to start out at 10,000. And then we have our loop. So we have that I, single letter variable that we're allowed to use when we're counting increments of a loop. I equals 1 is the initialization. And we're going to count as long as I is less than the years, or less than or equal to the years. So years was 10, so this is going to count from 1 to 10. Okay. And every time through the loop, we'll increment the year by 1. Or we'll increment I by 1 until it equals the value of the year. So this loop is going to run 10 times. And each time we're going to take the future value times the annual rate that we had here divided by 100. So 7 should be a percent, so we have to divide it by 100. We're going to add that onto the future value, and we're going to do that 10 times. And we'll find out that 7% for 10 years, $10,000 would yield $19,672. So we get this future value accumulates. It starts at 10,000 in this case. Right here we started at 10,000, and it accumulated interest every year for 10 years as this loop executed 10 times. And then when we're done, we print out the future value, and that to fixed 0 means we're not going to print any decimal places on it. All right, the formula we used in here, there's other ways to write that formula if we wanted to. This way is valid, that way is valid, so is that way. Pick the way you want. It's math. Just whatever's easiest for you to write. Let's look at another example of a for loop. This is a for loop. We're going to have I start at 0. And we're going to count up till I is equal to 10. And then in this case, we're not incrementing I by 1. We're incrementing I by 2. And then we're calling document write, and we're writing this to a web page in this case. We're writing the number plus a space. So what's going to happen here, the first time it's going to write 0 plus a space. The second time it's going to go up by 2. It's going to write 2 plus a space. The next time through it's going to write 4 plus a space, then 6 plus a space. So we're counting by 2s. Here's another example of a loop that decrements the counter. In this case, we're initializing our counter variable to 3. And we're going to count as long as the number remains greater than 0. And in this case, we need to count backwards. So we're going to count down from 3 to 2 to 1. We're not going to count to 0 because it's not greater than or equal to. When I becomes 0, this will fail and it will stop. So it won't actually write the number. So we're decrementing here, starting big, ending small, going down by 1. And we are writing the number plus dot, dot, dot. We're concatenating on the dot, dot, dots each time. So we get, and then when it's done, it writes blast off. So we get 3 dot, 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 then it's 2 dot, 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 then 1 dot, 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 and then that's where the loop ends, and it writes blast off. And that's what we end up getting then. All right, that's where we're going to stop for loops. And in the next couple of videos, we're going to actually look at some applications that make use of conditional expressions, our conditional operators, our different kinds of loops. We'll see those used in examples that should be familiar to us from previous chapters.